All right, guys, there we got some vector operations to go through. Should be a pretty easy day for you, but watch out for one word at the beginning, and you should be good to go. Component form, this is what I was talking about. Component form of a vector, I don't know what I just did. A component form of a vector, AC, vector AC, needs a little line over there. With A being xy and C being x2, y2, all you do is you do the terminal point minus the initial point. That's how you find component form. And what component form does is it takes a vector that is not centered at the origin, doesn't start at the origin, and makes it centered, not centered, but makes this the initial point at the origin. Just moves it down to the origin is all it does, or moves it up to the origin as its starting point. So all you do to find the component form is you do your x2 minus x1, and the order is important. So F minus C, there's my x's. Do the same thing with the y's. F minus the C, and you get 5 and 8. And that's the component form of vector AC, or sorry, vector CF. Taking vector CF, instead of beginning at -4, -3, makes it begin at the origin at 0, 0. All right, the length of a vector, or magnitude, is given by this right here. It's also the symbol is this. Talked about that a little bit yesterday. Looks like absolute value, but with vectors it means magnitude. And all you do is you take the square of this and the square of that and take the square root. Now, that's really the distance formula when you think about it, because to get the vector in this form, you've already done x2 minus x1 and y2 minus y1, which is the main part of the distance formula. So, find the magnitude or length of the vector v, 5, 8, which is one we just found. So to find the magnitude of v, you take the 5 and you square it. You take the 8 and you square it, which will give you the square root of 89, which is perfect. You can't break that down any, so we'll leave it like that. That's all you do to find a magnitude or the length of a vector. Scalar multiplication, if they put a number outside of a vector, like this, like that k, the k is called a scalar, spelled scalar, but it's pronounced scalar. And all you do is multiply what's inside by the scalar. So if it comes down here and it says that vector u be -5, 4, and vector w be -1, 1. And it says find -7w. Well, -7w, you just multiply both numbers in there by -7. So it'd be -7, +7. The second part says to find 3 times vector u. So multiply vector u by 3, which would give you -15. And +12. It's that simple. And the last one says -1w. So take matrix W and multiply by -1. Really just changing the signs. And that's it. It's all you have to do for scalar multiplication. Very easy stuff. All right. 2 more things here. Vector addition. When you're doing vector addition, all you do when you add the 2 vectors together is you just add the 2 x coordinates, add the 2 y coordinates, and get your new component form of a vector. Vector subtraction the same way. You take vector u, vector v, subtract u1 minus v1, u2 minus v2. That's all you do. Really not too bad. Let me show you one real quick. I'm not going to do all these because they're just not that bad. Nothing you can figure it out. Part A says vector u plus vector v. There's vector u is 7, 2. Vector v is -3, 5. So you would just do 7 plus -3. And you would do 2 plus 5. And what would you get? But 4 and 7. All there is to it. Now part B, a little bit different because it has subtraction and it has a scalar. So I would do vector u, which is 7, 2, minus 6 times vector v. So I'm going to go ahead and do 6 times vector v, which is -18 and 30. And then I'm just going to do the subtraction. 7 minus -18, same thing as 7 plus 18, which is 25. 2 minus 30 is -28. And just like that. That's the subtraction. Let's do one more, then we'll stop the video. Let's do the last one. It's got a bunch of stuff. Let me make this a little bigger for us. See that right there? Part D. It's the magnitude of 5v minus 2u. So I'm going to do 5v first. Let's change this to red. 5v would be -15 and 25 minus 2u, which would be 14 and 4. All I did is I multiplied the 2 matrices by what it said to. Let's do the subtraction. -15 minus 14 is -29. And 25 minus 4 is 21. But what it asked me to do is you need the magnitude of that. Remember how you find magnitude? You do the square root of negative 29 squared plus 21 squared. I gotta get my calculator and punch that in real quick. Hang on. And I got 1282, so it'd be the square root of 1282. And I couldn't find anything real quick to break that down with, so I'm just going to leave it like that. And that's all, guys. So you have magnitude, component form, addition, subtraction, and scalar multiplication. So not a bad day at all. We'll work on it in class tomorrow, like always. See you then.